Yeah, so like you said, my name is Ira Tarchis. I work in the IT department. I primarily am an AWS Cloud Network Engineer and Architect for IET, working mostly on IT stuff and interfacing with the research community on occasion on a particular project right now with the college engineering team. And yeah, today I'm just going to go through a few slides about AWS and hopefully not put everyone to sleep.
And my name is Jose Lope. I work with enterprise platforms at IET, so we help campus with strategies around platforms such as Salesforce, Cloud, AWS, and mobile. So we're very happy to be here giving a demo and talk for you guys to help you with your data sets.
All right.
So we'll get started here. I'm curious about just.
You guys have
stuff you're running and using in AWS right now. Okay, a couple folks. And how many folks have used AWS in the past or go forward with it for very.
Basically no experience with AWS. Cool, awesome. This presentation is not calibrated for that. What I'm going to try and talk about is basically what AWS is. I'll have a sort of philosophical
discussion at the beginning.
In general and how it relates to research in some way.
And then talk in general terms about what AWS is, describe some of the services in AWS, and then I'll go through a couple demos of interesting services that I think might appeal to people in
questions every so often.
So, feel free to jump in and ask me anything you want as I'm going along, but I will have breaks after sort of each section to sort of have discussion and ask some questions. I don't anticipate keeping you here for 3 hours to watch me present stuff. So hopefully, and hopefully it's interactive enough in terms of the conversation and discussion. Or all right, so research. So
Large universe
tends to be kind of a big cluster of different resources, and there's a lot of resources here at UC Davis that are available to folks who want to do research computing in addition to the cloud, and so there's a lot to think about in terms of what's the right fit. So I just wanted to put up a slide here to sort of list what kinds of things are available just to make people aware in a general sense of what's around. So there's various HPC clusters around campus if HPC is what you're looking for. HPC can be kind of expensive in the cloud, but it also can be very, quick and dirty and easy to automate. So there are advantages and disadvantages to running it in the cloud, but there are definitely programs on premises, on campus to help you with HPC. Before this presentation, Pamela and Bill Broadley got together and tried to put together a sort of an inventory, a list of all of the HPC clusters on campus for researchers to reference. And that's hosted at hpc.ucdavis.edu conveniently. So I think that's sort of a living document. People are adding to it, but it has HPC clusters, some information about them, and then who to contact. So if that's useful, that's available. The Bioinformatics Core offers grant opportunities to people who want to work on the genomics cluster. So there's some contact information for that. There's also local system development if the data you're working with isn't too intense or large, or you're just trying to learn about using data science tools. And the DSI, I actually attended the sort of Install Fest about a month ago here, and they're here as a resource to help you guys get started working with data science tools on your local systems. IET has some on-premises solution, the UC Davis private cloud. There's an email address there, esxadmin@ucdavis.edu. And then there's more information in the IT catalog, as always, for other IT resources that might be available to help you with your research. And then what we're here to talk about, which is cloud services, sort of the topic du jour of computing world. Cool. So just a brief sort of introduction to cloud computing. Really, the idea of cloud computing is basically grew out of what was a large internet boom. So internet companies were building huge data centers to house their resources to run the businesses they had online, and they were developing automation techniques and cost-saving techniques within those data centers. And specifically in the case of Amazon anyway, what they decided to do was sell those resources, commodify the resources that they weren't using in these large data center ecosystems, and sell them to the general public as computing resources. So they basically packaged themselves as the world's IT department, basically, and the world's data center. So in sort of a general sense, it's distributed infrastructure. So a big, huge operation that has a bunch of different data centers and replication and high availability and a bunch of storage is able to deliver computing services to the general public at a lowered cost because of economies of scale, basically. And so you basically run infrastructure, servers, networks, databases, whatever you want, on the internet at somebody else's data center. You access them from the terrestrial internet via your laptop, so it's completely virtualized. In general, there's a lot of layers of abstraction. So as cloud computing has gotten more popular, and we'll see this with AWS, a lot of these cloud providers have started not just offering, hey, here's a server, you can deploy a server, but offering things like databases as a service. So you never have to actually interact with the underlying server. They just give you a connection string and you can log into a database that's of infinite size, basically. So that kind of service model has been progressively becoming more the direction in which cloud providers are going. And that's good for consumers, and it offers a lot of like sort of ease of deployment for a lot of the tools we're going to talk about today. Pricing is typically based on usage. So it can be a good thing and a bad thing that you pay for your cloud server resources every month. So you don't buy a cloud resource once and then never have to think about paying for it again like you do with a regular server. They'll charge you every month. And it can get very expensive that way, but it can also be really cheap if what you're running is small or you don't need it for that long. Because they're large data centers and large organizations, they provide a ton of reliability in terms of the network uptime. They usually will automate your backups for you, all kinds of stuff. So all kinds of good stuff having to do with cloud resources. So there's a lot of good stuff about cloud resources. Generally, they're easy to automate, so deployments take less time. Most of these cloud companies have point-and-click interfaces that allow you to sort of deploy your infrastructure on demand as needed. You have functionally infinite compute resources, so compared to what you would get if you built a server room in your laboratory or signed on to a smaller organization's server cluster, you have basically infinite compute resources, whatever you can pay for. There's a lot of community support around a lot of the cloud providers. AWS is the largest, so it has a huge user base, and they're always contributing new things to the open source information suite that's out there about AWS. AWS itself also provides a ton of good documentation. So it's a good cloud to go with if you're not used to cloud infrastructure and you want a lot of documentation and a lot of online resources. And in a lot of cases, ready-made stuff that you can just deploy in a click and not have to worry about, barely have to think about. It's pay-as-you-go, so it's non-committal. I sort of talked about that earlier. And then they commoditize a ton of products. And AWS in particular is developing a lot of products to work with as commoditized sort of server services. And we'll talk about them in a minute. In some cases, an isolated AWS environment sort of separates you from your local network. and takes a lot of the security responsibility out of your hands. So if you have data that is sensitive, building a secure environment that's isolated in the cloud can be a good option because you don't have to worry about physical security. Most of the cloud providers, specifically AWS, have attestations all over the place about their physical security practices. The servers and infrastructure are usually, you can deploy high availability really easily, so you can make sure your stuff doesn't go down. You can configure backups really easily. So it's a good resource if you have data that you want to keep really secure. There's a lot of ease of experimentation in these environments. So if you want to try something on a big GPU server, but you don't have access to a GPU server, if you give a credit card to AWS, they'll let you deploy as many GPU servers as you want for as long as you want, but you can also deploy them for as short a period of time as you want. So if you wanted to test something out on a very large server, you could deploy it for a day or 2 days or a week, work on it, and then shut it down and not have to pay very much for it. Usually there's a single pane of glass for viewing all your infrastructure. So we're going to go through the AWS Console in a little bit, but basically you can look at all of the network configurations, all of the services you have deployed, all of the servers you have deployed through a single console. And AWS in particular and other cloud providers are trying very hard to make that sort of the single point of access to all your infrastructure. So there's a lot of tools in there to look at your logs without having to log into a server to look at what your database information and settings are without having to log into the database or run queries against the database schemas. And you can reproduce computing deployments easily. So this is something I'll demonstrate later, but basically this is very, very useful for researchers because the research community is developing a lot of infrastructure deployments that are applicable to many different use cases. And a lot of times they will publish them as part of the research that they publish. So AWS provides several different tools and has several different integrated tools to do things like deploy all your servers and all your databases and all your message queuing services and whatever else you might need to run an experiment or run your code by just basically taking a piece of versioned code off the internet and sticking it in an AWS Cloud Formation deployment scheme. So we'll talk about that in a bit. As with anything, there are good and bad things. There are caveats about cloud computing and things you need to be much more aware of than if you're doing things on premises. Costs really need to be closely managed. Costs can get out of control very quickly in the cloud, especially if you're deploying a lot of stuff. So it's important to keep a tab of what you have deployed and make sure you're shutting it down when you can. Subscription services don't always beat bare metal over the long period of time. So if you need something for 4 years and you deploy and you buy a server that's really big and you stick it under your desk, it may not be the most secure thing in the world. It may not have high availability, but you can probably use it for 4 years and only pay for it once. In AWS, you deploy a similarly sized box, you're going to pay for it every month for those 4 years, and it might get very expensive over that long period of time. So that's something to be aware of.
The cost is not a huge cost. And make it sound like it was like paying for each server each month. So it's a very small percentage versus buying a $10,000 server.
Yeah, yeah.
4 years, how much more expensive do you think it would be?
Well, it increases drastically as you start to use more fancy equipment. So if you need GPU servers, those can be really expensive to run in the cloud. And those really, like AWS won't let you deploy a GPU server without requesting it directly from them, a limit increase, because they can get very expensive and they don't have the resources to support it necessarily. So over the long period of time, I would say certain types of resources can be much more expensive than they are on premise. It's not, my opinion is it's not always cheaper to run things in AWS. For research, it can be though, because if your research cycle is 6 months, you may not want to buy a system that's that's built to last for 3 years. What's the point? But over a long period of time, if it's a very expensive type of resource, it can get pricey.
just to add a little bit on that, you know, how many of you run some analysis for months at a time continuously? If you don't, then cloud can be cheaper because you literally pay for only what you're using. To extend the example that Ira gave, if you have something that needs to be available for 4 years and running that amount of time, that's where some hardware on premises could be there. I think it's a more rare use case for data scientists, for you all, but it's something that when we're talking about the drawbacks of cloud, it's something to definitely be aware of.
Yeah, and if you're comfortable with automation and you're comfortable writing scripts to build your systems, you can leverage that much better in the cloud, because you not only can automate the configuration of your systems, but you can automate the actual deployment of the hardware itself. So I'll have a demonstration in a little bit about sort of a microcosm of what that looks like, and then talk a little bit in a minute about what AWS has available to you that's like ready-made. So resources you can spin up, they're configured the way you want, they have the applications you want installed, and all you have to do is go to a web page and log in, or sign into a console or something. There's a lot of that going around, and that's what cloud has really accelerated, is learning how to manage your resources by deploying them only when you need them and keeping them as stateless as possible, and separating the stateless parts from the stateful parts, like your data store. So those are kind of key concepts in cloud computing, and I'll have a case study that sort of describes stateful versus stateless and stuff later on. So hopefully that will be clear. Security isn't managed by a central IT organization, usually. So IT is sort of dipping our toes in the space of trying to provide secure environments within AWS, and at the end of the presentation we'll go over what that looks like right now and what the future state might look like. But generally, this is a consumer product. So if you go and you open an AWS account, like all you need to open one is an email address and a credit card, right? So you just Google it, search it, open one, you deploy a bunch of servers there. AWS will handle the physical security, but you're responsible for the firewall rules, for the network ACLs, for the routing, for everything related, everything that IT takes care of here, basically, is going to be your responsibility for cloud resources. Not a ton of like really complicated or difficult stuff, but things to be aware of. Formal support can be difficult to get when things go wrong. So, you don't necessarily enter into a contract with a cloud provider. So there's not someone you can call on the phone or email necessarily, but you can purchase support plans that will give you some help. It's just not the same as like a licensed product necessarily all the time. Yeah, and then infrastructure management, how things are configured, whether they're working or not, whether they're being backed up, no longer IT's responsibility. It would be the responsibility of you in most AWS environments. All right, so that was sort of general cloud discussion. Does anyone have questions or things they want to sort of ask up front or contribute before I get into like specifically what AWS looks like? Cool. All right, so now I'm going to talk a bit about what AWS is. So AWS services both is and are very big. So AWS is huge. It's got 90 plus services, and it's more than that. Because a service, anyway, it's a ton of stuff available in AWS. I would never call myself an AWS expert. I don't think anybody should, because it's just impossible to be one. There are 90 plus services, meaning, and they range from, elastic MapReduce clusters that can do, run custom MapReduce Java on, inbound data, to, a server instance, to networking infrastructure, to, web pages on demand, to artificial intelligence and machine learning algorithm services, to all kinds of weird storage services and query services. So it's a ton of stuff, and they serve a ton of different purposes. So I'll talk about that in a minute, but there's a high level of feature support and development. That's what caused this huge boom in services. AWS is constantly adding new services. It's like every week there's some new suite of services that they've offered. Every year at AWS reInvent, which is in a few weeks, and if you plan on using AWS, it's a good conference to attend, although pretty big. They usually announce at least 15 new services every year, invariably. So it's a ton of stuff, and that can be good, but it can also be daunting and overwhelming. And I know because I just made a presentation on it. So not everything you want is probably going to be covered here. There's integrations with a ton of other services. So people are constantly developing against AWS. It's a really in-demand kind of environment, and a lot of companies and universities and government entities are moving their stuff to the cloud. So there's a huge marketplace for tools that integrate with AWS, and people are definitely developing against it. So there's a lot of things to help you out there. It's really well documented, like I said earlier, huge user community. AWS itself provides great documentation. If as a beginner cloud, it's fantastic. I think it's the best one to use if you're just starting out. It's highly distributed, so there are 15 regions, 15 plus regions actually, to choose from, and each of them has multiple data centers. So you shouldn't ever lose anything in AWS, basically. Reputation for good security practices and reliability. So it's Amazon. Amazon doesn't go down. And there's a ton of use cases. So I'm here presenting because I work on AWS and IET. I think that's probably, hopefully this will be a good introduction, but I can't even pretend to know what your use cases are. The ways that you can do it, the things that you can do in AWS, the fact that they have hundreds of services, there's just no way I'm going to be able to talk to all your use cases. So if you have questions, definitely reach out to me afterwards and get involved in the community here on campus. There's some good resources that I'll talk about later for that. But yeah, a lot of companies use it to publish their web applications. Where I used to work, that's what we did. Every week we'd push an update to our web application, and it was a fully automated development pipeline. That's really common in AWS nowadays. Internet of Things deployments, because AWS has so many tendrils going out into the internet, it has edge locations, every 50 miles. So if you have a low round trip requirement for data loggers that are in the field all over the place or something like that, AWS is a good solution because it has so much internet infrastructure out in the world. And you have access to that. So there are the 15 data centers, but there's also content delivery networks that AWS runs that allow you to get even closer to where your endpoint is ultimately. There's automated call center applications. People use it for that. Image processing and data mining, graph databases, data warehouses, and recognition like image search processing. Those are huge things. High performance computing. AWS has done a lot of stuff recently around high performance computing, and I'll show where those resources are for you guys who are interested in that. Full clusters that you can just deploy into the cloud for high performance computing in a minute. Short-term compute resources if you need something quick. They also offer spot instances, which is like a marketplace for bidding on compute, basically. You can use that short-term of use cases. Machine learning algorithms, they have a ton of work lately on machine learning. Storage and backup, so people are probably using this, S3 and EBS, and static web hosting. So if you have a web page, a lot of people host it on AWS. I'm curious, like, of the folks in here, did anyone come with like a specific use case, something they're looking at in AWS, but came to sort of hear about? No? Yeah.
Image processing, data mining.
Image processing and data mining? Yeah. I may talk about that, probably not. But I'll talk about some of the services that are available. Yeah.
Currently using it as a data storage, MySQL database.
Okay.
Thinking about migrating to a graph database. So.
Okay, cool. Yeah.
Run big data.
Run big data. Yeah, with like R or MapReduce or Spark or something. Yeah. Cool. Okay. Yeah. That I'll talk about quite a bit. The other two, I will definitely mention and bring up the services, and I can talk to them a little bit. But if you want to talk more, see me afterwards. I can give you a little bit of primer on each of those. Anybody else? Cool. So yeah, I've talked to death about the advantages of using the cloud for various things. A couple that I want to hit on are like it's self-service, so you can get the resources you want when you need them, which is cool. Most everything's really quick to implement. A ton of third-party support and scaling. So you need to make something bigger, it's easy to make it bigger. You need to make it smaller, it's easy to make it smaller. Some just myths. One is it's cheap. It can be. It's not always cheap. And so don't think about it as a cost-saving thing unless you really know that it will save you money. And do the work ahead of time. I'll go through some of the resources AWS provides later on to do your cost analysis. It's complicated. It's not that complicated. It's pretty easy to use. If you're familiar with computers, you should be able to get a system spun up pretty quickly. It's only for application developers now. I mean, you can use it for whatever you want. It's so broad that it serves a lot of different purposes. It's only for IT folks? Absolutely not. It's not even really for IT folks. It requires a lot of technical skills. Nope. And it's not secure. It can be very secure. It can also be insecure. It's not supported at the university. We have a BAA with them. It is supported. And it's a fad? Probably not. It's hard to get. It's not. All you need is an email address and a credit card. You can get AWS. Easy. You can also go through IET for invoice billing. We're going to make that easier too. What an AWS account gives you. Oh, okay, there we go. Okay. AWS account gives you access to its worldwide data center network. So each of these little dots on the map are AWS data centers, and there's numbers in the dots, probably easier to see over here, like North Virginia 6. So this is the original AWS data center. It has 6 what they call availability zones. That means 6 data center campuses in North Virginia that AWS has, usually separated by miles and miles. So when you log into the console, you get access to deploy your resources in any of the availability zones, or all 3 of the availability zones if you want. So you get to manage the redundancy of your services, which is nice. And you get access to that big data warehouse. Interacting with AWS comes in a bunch of different flavors. Probably the most common one is the AWS Command Line. So AWS has a pretty robust command line for doing like general querying and stuff. It's pretty simple to learn. The command is AWS and then whatever service you're using, and then whatever let's see. Probably not at the moment, but anyway, it's got a pretty robust command line interface. It returns JSON or YAML, whatever you want, and you can use this for a lot of automation use cases. I'm not going to get too deep into the command line because I think people are more comfortable generally with the GUI at first, but that is available to you guys if you have an AWS account. It also has a ton of SDKs for the people who do a lot of programming around here. So Python has a really robust SDK called Bodo 3 now, Bodo. It allows you to basically interact with any AWS service. You can deploy server instances from Python. You can deploy databases. You can connect services to one another. You can do all of that with Python, Java, more sort of formalized programming languages, and specialized Ruby, Go, C++, .NET, all are supported and have AWS SDKs that you can use to interact with AWS services. Easy to start using too, very well documented. The last sort of highly technical one, and one I'm going to talk about a little bit more later when I talk about automating infrastructure deployment, is AWS Cloud Formation. Cloud Formation is a really nice service. It basically provides a templated version of your infrastructure so that instead of having to go into the console or go on the command line or develop a new Python app to deploy your services, you basically, in a sort of specialized text file, you just map out what you want your infrastructure to do, and then you have that as text, and every time you want to redeploy the infrastructure, you stick it into AWS and it deploys as a file. Basically, it'll launch all the resources. So I'm going to demonstrate how that works in a little bit. What this really offers is portability. So if somebody builds a network and a system, a collection of resources that you think is cool or you want to use, they can document it in Cloud Formation, and you can deploy the exact same thing they deployed into your environment. So
Think of how useful that would be for sharing across with your PI or your fellow grad students or postdocs, or publishing.
And I'm gonna talk more about Cloud Formation later, because I think it is really a good tool for people who want to get started with AWS. The AWS itself has published a number of quick starts, which are basically just Cloud Formation templates that you stick into their system, and it deploys all the resources that you need. We built one quickly for this demo that you'll have access to at the end, that deploys like an RStudio server and Shiny, like without doing anything, any configuration basically. So you can do things as simple as that, and you can do things as complicated as a use case I'll talk about a little bit later. And then there's the AWS Console, which is a graphical user interface for services. So the AWS Console, this is sort of the view most people are familiar with. It's basically, what I'm looking at here is 5 different servers that are all turned on. This is part of the EC2 service catalog, but I have access to consoles for every AWS service. So this is just a listing of some of the AWS services. I don't even think they're all listed here. So yeah, this is the Goliath monolith or whatever of AWS services. This is EC2 services. This is what I'm going to talk a lot about today, because EC2 instances are sort of the virtualized server infrastructure. So probably the most familiar type of environment for you guys, and for just people who haven't used a lot of cloud services in general. And they probably provide sort of the quickest on-ramp because they're the easiest to manage, certainly. But yeah, like I can see here that I have 5 EC2 instances running. If I wanted to connect to this Windows tool server, let's see. I could, let's see.
And on Windows, you must have this putty gem, right?
Yeah, for a Windows server, I can connect via the RDP. So I can connect via remote desktop. So what I need to know is the key pair name. So every one of these instances is deployed with a private key pair. Mine is located probably in my oh, here we go. All right, well, I'll demonstrate how to connect to a Linux instance a little bit later on, but basically, for some reason, I have 3 server instances deployed that I don't want, so I can just turn them off pretty easily here. So I'll terminate that instance. That basically stops AWS from charging me for it. Additionally, each instance is backed with a bunch of different subcomponents of AWS. So AWS uses what it calls elastic block store for the server storage components. So these are like storage volumes, kind of like disks on your existing server, and you can configure those by modifying. You can modify the size. You can You can encrypt them by copying them. You can take snapshots of them to back them up. Yeah, lots of different like easy services to use to like basically manage your infrastructure environment. That's, you know, if I wanted to expand this disk from 50 gigs to 100 gigs, it's as simple as just going through the UI to do that. And now this disk on this root disk for this server is going to expand from 50 to 100 gigs. So that's nice, a nice feature of AWS. Also, I can control access from various network endpoints by managing the security groups that apply to this instance. And I'll talk a little bit more about security groups later on when I talk about the VPC. But these are basically network permissions. So right now, there's only access to this server on port 3389, which is the remote desktop port, from this IP here, which is my IP currently. Yeah. And I can sort of, let's see, I'll just demonstrate how to get access because I found my file. So, I have a very clean desktop, it looks like. All right, so I put in the private key for this server. I can grab the password now and log in using remote desktop to the server in the cloud. So it's telling me the username is administrator. So I'll go ahead and change the login to the local administrator. And I can click this button to copy the password so I don't have to do it myself. And oh, it came down here, but Windows desktop. So it's logging me in. This server exists in the cloud. I can use it like you would normally use a virtual machine, nice and easy. Launching these servers is also really easy. So if I click the launch instance button, it's actually like dangerous how easy it is. I get access to a huge list of different images that I can use. So these are called Amazon calls them AMIs, Amazon Machine Images. So they're basically state captures of a system that you'd like to deploy. And Amazon has a lot of base level ones, so that's what's showing up here now. Amazon has its own brand of Linux, which is cheaper to run on AWS than anything else. And it works a lot like CentOS, if you're used to that, or Red Hat. It's a Fedora flavor. Anyway, so I can deploy an Amazon Linux instance, I can deploy a Red Hat instance, and it will charge me for licensing. SUSE, Ubuntu, they have various AMIs that are specialized for certain purposes. The deep learning AMI has a ton of documentation, so if you're interested in machine learning or doing that kind of compute, if you deploy this AMI, it comes with a suite of tools to do deep learning and analysis. It costs a little bit, so each of these, if I select one, it will show me an option of what type of instance I can deploy. So you can see it's a pretty big menu. I get to choose how many cores I want, what level of memory I want. It conveniently is not showing the price here, but they have a price list online. The prices differ per region, so beware of that. Right now I'm in region Oregon, which is US West 2, but basically I could move to any of these other regions and I would see the same suite of tools and I could deploy my resources there. Yeah.
Question is that, is there any reason that you wouldn't just kind of unpack and find the cheapest place?
No, except unless it's like across the world. Usually the cheapest places are in the US. So no, not really. We deploy a lot of stuff to Oregon because it is cheap and it is on the West Coast. But yeah, there's North Virginia. If you're not too concerned about serious latency, there's no latency, but if you're not super concerned about latency, North Virginia is usually fine for things. That's usually the cheapest because they have the biggest data centers and the most of them. But yeah, you can look online for, it's easy to Google. Why not Google? Yeah, there's, you know, this is typically what I do, which is maybe embarrassing, but it's easy to just see on-demand pricing, and then I get a list of the prices for the different instance types based on OS. You know, I can look at what Windows is charging. Windows typically will package the Windows license with what the server you're deploying unless you specify otherwise. So you're getting charged for the Microsoft licensing fee as well as the server. That's true for almost every one of these AMI tools that you can deploy. So yeah, you'll also notice that there's this little tag here that says free tier eligible. I'll talk more about what's free in AWS a little bit later. Turns out not a whole lot, but there are some EC2 types that are free. So the T2 micro instance, which you can see has 1 CPU and 1 gig of memory. Yeah, thanks. It's not going to be great for you, but it is free if you want to just try something out really quickly. So yeah, you know, easy deployment. I go to the next screen. There's a bunch of gobbledygook that I don't understand, and if I don't understand it, I don't care about it. I'll talk a little bit about what VPCs are. This is the virtual private cloud. These are sort of core infrastructure components. And then, yeah, I can talk a little bit more about subnets as well when I talk about VPCs. But basically, I can go through this, add some storage, whatever I want. I'm going to rack up a bill here today. I can name the instance. Demo deployment. I'm going to call it a deep learning demo because why not lie? Oh yeah, it doesn't like my choice of port. That's okay. So it's warning me that the security group that I've assigned to this instance does not have port 22 open from my IP. So I won't be able to connect to it via SSH because that's the Windows security group, but I'm okay with that. I click launch. It asks me for a key pair. Remember, each instance is deployed with a key pair unless you tell it otherwise. And so that key pair is what I'll use to SSH into the system when it comes up. I launch it, and as easy as that, I basically just accepted all the defaults. It will launch a deep learning demo instance that I will be able to log into. Cool. So that's the AWS console. That's just the EC2 console. There's a bunch of consoles for S3, which is their Elastic Storage service for the database. Everything has a GUI. Every service has a GUI. Almost every service is as frighteningly easy to deploy as that, and some of them are very expensive. So just another, caveat about that. All right.
This is great, but you say very expensive. What ballpark is it?
So if you deploy an EMR cluster with like 3 GPU nodes, it can run, $2,000, $3,000 a month, maybe more, depending on the size of them. Like here, I can actually pull up that price list, and you can see how much things cost. So if I go way down here to, let's see, there's some GPU 3X S large is $1 an hour to run. So that's the smallest GPU node is $1 an hour, 93 cents an hour. So yeah, you can imagine over the course of a month, 750 hours, it's going to be $750. The larger GPU nodes, this one's $5 an hour for this memory optimized node. They can get expensive. Those are EC2 instances. And if you add services on top of that, or you look at database services, RDS instances, which I'll talk about in a bit, those are more expensive still. So if you want big compute, you probably will pay some money for it. Potentially not as much as you pay if you buy it for your lab, but still it's going to cost something. Is that good? Cool. So that's the GUI. That's probably the most friendly interface. I'm going to get into the different services, and I'll go back to the GUI a bit later. Is there general questions about interfaces with AWS or just general information about AWS that I can answer? We're going to talk about purchasing and buying it and stuff too. Yeah.
Alternatives to the GUI?
Yeah. So I went through them pretty quickly earlier. There's basically 3 different alternatives as I see it. Well, there's more, but 3 different native alternatives that AWS supports or builds. So the first one is there's a command line interface that does everything the GUI does, and actually does more. You can do more, a few more things in the command line than you can in the GUI, though they're building that functionality into the GUI. It's a really robust command line interface, and it's if you're working with AWS and you're really comfortable with the command line, it's the one I'd recommend. The GUI is nice, but it's clunky and you have to point and click, which is not fun sometimes. So that's one. There's SDKs for almost every language. Not every language. Most common languages have an SDK. And the best one that I've found, I haven't used all the other ones, but the best one that I've found between Node and Python and Ruby is Python's is really, really good. The Bodo module is great.
So can you
Does-
deploy an instance from?
Yep.
within? Oh,
Yeah. Yeah, you can deploy an instance from any of the programming languages. Yeah, we have developers in IET who just deploy their own infrastructure using Java, which is weird, but it works.
Just an acronym check. Everyone knows what SDK stands for?
Oh, it's a software development kit. So it's like a programming language plugin. Or a module for a programming language that you're using so that you can write functions and things to interact with AWS, basically.
It may be a little hard to see on the slide, but for Python, the Bodo 3 is just a package you import as per normal. So if you're importing pandas or SciPy, whatever, you do the same thing with Bodo 3. It's just a package that lets you interface with Amazon Web Services.
Yeah. Yeah, so it's a so yeah, sorry, that's one of the interfaces, and then the other one is it looks more intimidating than it actually is, but it's just templated architecture or infrastructure as code. So Cloud Formation is the tool that AWS natively supports. There are great other tools like Terraform is something. If you're automating a lot, Terraform is something I can't recommend highly enough, and I'll talk about it later on. It's not really an alternative to Cloud Formation because I think they serve different purposes, but it's similar in terms of you being able to automate a bunch of AWS infrastructure in a single file and deploy it all at once, and then deploy it over and over again. So yeah, those are the alternatives. Any other questions around AWS stuff? Yeah.
You can't save money using AWS stuff.
You can.
You keep saying like, oh, it's really expensive. I'm just saying.
You definitely can, yeah. Yeah, so the key ways that you can are, one, a lot of smaller services are cheaper. And if you want something for a short period of time, it's definitely going to be cheaper. And if you manage it really well, it will probably be cheaper. Yeah.
But like one of the cases we have an RDS instance that's like 50 gigs
Yeah.
of data. But yet that costs us literally like $100 something a month, which is really cheap as us buying a box.
Yeah.
You know, the equivalent.
Yeah.
You know.
Yeah.
We're completely saving money on that.
Yeah. There's definitely savings to be had in AWS. It's just be aware that it does, it can run up a bill. Yeah.
Are you going to go over the VPC, the security rules, and the IAM role, and all that kind of stuff?
Yeah. That's next. Core concepts are VPC and IAM, basically.
Okay.
Yeah.
If you make an instance via the GUI,
Yeah.
can you get Amazon to essentially print you out a Cloud Formation equivalent text file? So you can then share that later.
That's
a text file.
I've never looked into whether you can actually template the architecture that you've already built. It doesn't seem like it would be that difficult to do. So maybe they do it. I've not tried it, but I I think that at one point we actually we had a use case for something like that. This was like 2 years ago or 3 years ago, and it didn't work, and we couldn't get it done. So we ended up having to, basically, if here, I'll just go through this real quick. But like, if you pull down the description of an instance using the command line interface, it uses the same nomenclature as a CloudFormation template. So you can kind of build it off what the spec is being given to you through the command line interface. And CloudFormation accepts both JSON and YAML formats. So since it's replying to you in JSON, or me here anyway in JSON, I could use this to sort of as a baseline for CloudFormation templates. There is another tool called Terraform, and that tool, they released a new version like this week, and that new version is supposed to have support for doing for certain services doing that, importing them into Terraform templates. Terraform works very much like CloudFormation. It's just a third-party tool, but it interacts directly with the AWS APIs. But it's the same kind of idea. You template out your architecture in a text file, you run the Terraform executable against your AWS cloud with your credentials plugged in and stuff, and it will deploy your infrastructure the way you've designed it. Yeah, so Terraform is the tool I would recommend for trying to do that, only because I don't know if CloudFormation supports that or not. Okay, any other questions before I move on? All right, just go through some core concepts here. These are, they can get a little bit technical and complicated. Normally, if you're just working in AWS and you just want to do something simple, you don't have to worry about any of this stuff. You get your account, you get some login credentials, you can log into the console, and you can do whatever you want. You don't have to worry about permissions or what permission services have, and services will deploy their own sort of interactive permissions and stuff. But what I'm going to go over now is two components of AWS that sort of are overarching services within the AWS environment, and that's IAM and VPC. So IAM is like, what I would liken it to is Active Directory, which, if you don't know what that is, when you come onto campus and you punch in your username and password into your computer, you're automatically logged into a central authentication service, which is called Active Directory, and it provides you with group permissions and a bunch of other stuff that give you access to file shares and websites and everything else around campus. IAM is basically that for the AWS cloud, and it can be as simple or as complicated as you want it to be. Services interact using IAM permissions. So in AWS, if you want an EC2 instance to be able to connect to an S3 bucket, and if you don't know what that second thing is, I'll talk about it a little bit, but it's basically an elastic storage service. If you want those two things to interact with each other, they will interact using IAM credentials and permissions. So the IAM console, let me get to it real quick. It looks like this. So like, this is my account right now. I have 2 users in this account. If these are just users with various permissions that I can assign. If I click on one of them, I can see what their permission level is. So this one has administrator access. The other user has not administrative access. It has full access to IAM, and it has just service catalog and user access. So it only has access to a few services. So using this, if you have a staff of researchers or somebody you want to give access to the AWS console, you can do a little Googling, figure out, AWS has a ton of, they provide you with a bunch of, built-in policies, and you can sort of Google what these are, but they're pretty self-explanatory. So if I go to EC2, since we know what that is, I can see that there's some that are like I can't expand this, but there's some that are like read-only EC2 roles. There's some that allow people to deploy, some people that allow people to deploy but not delete services, that kind of thing. So basically, you can manage permissions pretty granularly with just the default permission sets. Yeah, so and you can put users into policies, and there's the idea of groups. You can deploy users into a group, and then you can manage a user's security credentials from here. So AWS supports multi-factor authentication. I definitely recommend you enforce multi-factor authentication on your AWS account, which means using Duo to log in. The service is pretty easy to configure. Let's see. I don't know who I'm logged in as. Might be logged in as this guy. Yeah, so if you have Duo, you can just use Duo. Duo app has a little camera. You can take a picture of this QR code, punch in a number, and it will configure MFA for you in AWS. Very easy. If you have Duo on your phone, or Google Authenticator works too. Basically, I recommend it because it's just two-factor authentication. Do people know what that is generally? Cool. All right. There's also API credentials. So these are like access keys, and the private key, it won't show me the private key. If I need to get the private key, I need to delete one and recreate it. But basically, these are for using the AWS CLI or the SDK that gives you API access keys. Yeah, so that's the AWS IAM user section. Roles are similar to user accounts, but they can be assigned to objects in AWS. So you can assign a role to an EC2 server, and then that EC2 server acts as a user in the AWS environment with the permissions that you assign to the role. So if I go to a role, the screen looks a lot like a user's screen in that it has, this one like has a glue service role and other things. So yeah, so these can be assigned to like actual objects within the AWS environment. And AWS deploys a lot of these on its own because like in this case, this glue service needed access to S3, so AWS needed to provision an IAM role so that glue could get access to S3. So that's IAM. It's a lot. Yeah, so were there specific questions you had about IAM? There's a ton of stuff in here. You can store encryption keys in here, so you can encrypt your storage at rest pretty easily within AWS by creating an encryption key and assigning it to your block storage, that kind of thing. Yeah, so I don't want to make it seem too complicated because most of the time, for most use cases, you're never going to have to worry about this. You want to create users, you can give them simple policies that make sense to you, or you can not even create any users if you're just using the AWS account yourself. You just log in with the credentials you originally create. And most of the time, AWS will do the work for you. But yeah, there are ways to modify the policies. So it's customizable, and you can spec it out that way too with JSON. Yep. You can create your own custom policies as well. That kind of stuff is, yeah, maybe you don't ever have to do that. It's just kind of something you could do if you really wanted to granularly manage permissions or something. All right, so that's IAM. Yeah, so basically all the typical access control concepts apply. I would say the most advanced thing you guys would probably end up doing if you're just starting out with AWS is maybe creating a few user accounts for people who you want to access the AWS account and assigning them some kind of permission. You know, admin permission or read-only admin permission. All of those are sort of standard templated policies that you can just assign to a person. So, but it does get more complex if you wanted to.
Because this stuff is so, I guess, noodly and complex, IET is kind of working through trying to find an easier way for you guys to get access to this, to these resources without having to worry about a lot of this. It's important that we talk about it here at the outset, because security is something that we all have to think about. It's not something in the realm of IT. If you're using something like cloud computing, you're taking on the responsibility of security, and UC Davis takes that pretty seriously. So at IT, we're trying to find ways to make it easier to, facilitate that good security posture for you guys. But it's important that you guys know that it's, your responsibility to know this stuff and to be able to set it up correctly.
Yeah. So I'm just going to briefly go over VPC. Every resource in AWS nowadays is deployed within a VPC. VPC is just the network context for the resource. So what its network interfaces look like, what IPs it gets assigned, that kind of stuff is dictated by the VPC concept. VPCs are basically virtual private networks, so they allow you to provision private subnets to instances. Probably not something you're going to need to do too often, but the VPC console in AWS is where you would go to manage that stuff if it does come up. So if you need to manage network access or permissions or firewalls or something, all of that is accessed through the VPC console. Unless there's really a lot of specific interest in this, I don't want to get it too complicated. Networking can be very complicated. AWS, by default, in most cases, makes it very simple for you. And what I would say to worry about mostly is the security groups which are assigned to your instances. Make sure they're locked down to IP ranges that you're coming, you're logging in from. Make sure they're locked down to the ports that that you use. So, for instance, if I go to EC2 and I have my newly deployed deep learning demo and I need to manage access to it, the VPC component is completely, I don't need to worry about it. The VPC is configured for me to get access to the resources in the cloud right now. I don't need to worry about futzing with the network or the subnets or anything like that. All I need to know is that my server has a public DNS name and a public IP, and that I can get access with the IRA test key pair, and then I need to check what the security group allows me to do. So in this case, the security group is configured for Windows boxes on 3389, so I need to add SSH access for myself to get in, which is port 22. And from here, I can just select my IP, which is a nice handy thing, and it'll populate my IP address. So that keeps that instance secure. In other words, someone from a different IP address is not going to be able to SSH into my machine. That's very important. That's probably the most important network security concept that you will ever have to worry about if you're just deploying instances to do research. There is, it's good to be aware of what the VPC governs, because you may have an occasion to need to look at your network firewalls or set up VPC peering, which is private network connections between VPCs, or deploy a new VPC or configure the routes in your VPC or something like that. But if your use case is pretty typical, you probably won't, and this is what you'll have to manage, the security group associated with your instance. So if I click Save here, and then I go to my instance, and I go here. I should have probably demonstrated the failure first, but rest assured it would have failed if I had tried this before. Basically in PuTTY, are folks familiar with PuTTY? I'm assuming. Okay, yeah. So AWS does key auth. So I put the public DNS name in here, so this is resolvable in the public. I could have also put the IP address, if that's more sort of familiar to folks. Now I don't have either good one. Okay, so I can put that in. SSH, like I said, AWS does key auth, which means you have to go into this lower menu in SSH and browse to your key. You'll have to translate it from, it gives you a PEM file, you'll have to translate it to PPK. People who are familiar with PuTTY should be familiar with that process, assuming you use PuTTY-gen to kick the key out. Okay, and then I click open on the connection. And maybe I disconnected from that. trouble with the demo. Okay. Well, anyway, when this pops up, I'll log in with a standard username. For EC2 instances, it's EC2 user. They tell you that when you deploy the instance. For Ubuntu, it's Ubuntu. For CentOS, it's CentOS, which is why it's very important to keep your security groups locked down, because everybody knows those default names. That's not going to work. I'll just move on. Basically, that security group component is what I would really recommend being aware of. There are other components of VPCs in terms of they basically have the VPC configuration contains all your subnets, network routes, firewalls, load balancers, internet gateways, server instances. It all exist within the VPC, but you manage your server instances through that EC2 console. All right. Just some more concepts about VPC, and then this is just a diagram of what VPC components look like. So your EC2 instances sort of live in a subnet, private subnet range, which lives in an availability zone or a data center, and that data center can be you can have two availability zones within a single VPC. So AWS makes that network continuous between those two availability zones, which is nice because then you don't have to manage networking isn't separated between data centers. But really the concept is not super relevant for the basics. So there are questions about those complicated things before I move on.
He did throw a lot of information on you, so I'm not sure how folks are feeling. Do you want to take a 5-minute break before we get into some of the basics? Or do we want to just plow through? Break? Yeah. Let's take a 5-minute break. It's 10:10. We'll start up at 10:15. You can get up, stretch your legs, things like that.
But I just want to visit a couple services before we get into demonstrating a quick demo of what's possible within AWS on it, just with simple basic knowledge of the tools. So I'm just going to talk about the basics. So there's some low-hanging fruit use cases for AWS, I'd say, for researchers. Deploying and connecting to simple SQL databases in AWS is really easy. So if you need a SQL database as a service, you can use AWS to connect to that. Backing up and storing data in AWS is really easy with Amazon S3. Running a simple server-based applications in AWS is also easy. You can use EC2 to do that. We kind of talked about that. And automating simple infrastructure deployments in AWS using Cloud Formation is also really easy. So each of these concepts I'm going to sort of discuss in a little bit of detail, but I'm going to try and keep it brief and then get to a quick demo. So the first thing I'm going to discuss is the first thing on that list, which is database services. Amazon has a bunch of different database services. RDS is the one I'm going to talk about right now. That's the relational database service. So SQL servers, of varying kinds. So they support MySQL, MS SQL, Oracle, Postgres, and their proprietary relational database, which is called Aurora, kind of like SQL. Or kind of like MySQL, sorry. You can automate backups easily on these databases. You can configure them to be highly available, meaning distributed across data centers, so that if one goes down, there's automatic failover. You can resize them on the fly, which is actually really nice. We used to do this a lot with a production application that I supported with a database that just kept having problems, and we kept bumping the size up, and Amazon will do it and keep the database online and configure it entirely for you. You just basically have to select what size you want from the menu. And failover scenarios are managed by AWS. Upgrades are managed by AWS. All of that can be managed by AWS. And they come in a ton of different sizes. And then you can connect using your standard tools. You can create an SSH tunnel if you want, or you can connect directly to a connection string with a normal database account. So
Free service or?
There is a free tier. So I'll show you what the free tier is. If I can get the console over here. All right. So again, like just getting around the UI, if you just open up the services tab and type in whatever service you want to see, I'm looking for RDS, which is database service. It supports text-based searching. So yeah, and then this is the number of database services. I'm only really going to talk about one, but like Neptune is the graph database service. Elasticache is an in-memory cache database service. And DynamoDB is a NoSQL database service. But anyway, there's a bunch. EMR is Elastic MapReduce, so a bunch of Hadoop cluster options if people do that. But we're just talking about a simple RDS SQL. So the interface, again, is really pretty straightforward. I go here, I click Create Database. It gives me the options of which databases I want to configure or deploy. I'll pick MySQL. I can check this box to only enable options eligible for RDS free tier if I wanted to just try it out. So yeah, you'll notice that because I checked that box, I can only deploy the DB-T2 micro, which is 1 virtual CPU and 1 gigabyte of RAM. If I go back to the old screen, uncheck this, I can deploy, it has more options because I can deploy as a production service, which means it'll distribute it across data centers and make it highly available, yeah.
One thing I found with RDS is you cannot shrink the database.
Yeah, you can't shrink them, that's true.
Be careful of getting belly and go, oh, I want a 100 gig database.
Yeah, you can't shrink the size of the data, the size of the backend, the storage on the database. You can't shrink the size of EBS volumes either. Basically, shrinking things is very difficult. But if I turn off the free tier lockdown, I can see all the different things I can get. You can get up to a very large database if you wanted. Again, more expensive. We'll stick with the free tier, which is always the T2 micro version of things. So 1 CPU, 1 gigabyte of RAM, you get 750 hours of runtime of this as part of a free tier, which is enough to run it for a year. So I have to configure some things. The size of the database, 20 gigs is fine. I can pick which storage type I want, optimized SSD or just general purpose stuff. If that's matters to folks, I can name it something. I can give it a master username. I'll just call it root. Password. You can choose which VPC to deploy it into. Again, the default VPC works great. It's all configured for you. If you have other VPCs, you'll get those options there. You can determine whether it's going to be publicly accessible. So if you're only going to access it from services within AWS, you can make it private to AWS. If you want a publicly accessible string on it, you can ask it to give you a publicly routable name, basically. And you will control access to that publicly routable name, again, through security groups. So I can, I'll name the DB, the primary DB. It's telling me which port it's going to connect onto. I can configure how often it's going to be backed up. So it's going to be backed up. It's got a note about the storage engine, but I wouldn't worry too much about that. It's going to retain backups for 7 days. It's going to back it up daily. Actually, it's going to back it up on a point-in-time recovery basis, so I'll be able to recover point-in-time by default. I can enable enhanced monitoring, which will ship the AWS logs out so that I can see them outside of the database or ship the SQL logs so I can see them outside of the database without having to log in. And I can select which log types I want to log to AWS CloudWatch logs, which is a service that allows me to see the logs outside of the database, basically. I can tell AWS to upgrade it for me, and I could configure a maintenance window if I wanted. If you only wanted to go down on the weekends or something, you can configure that there. And then I click Create Database after configuring those basic settings, and it starts creating the database. let's see. So when it deploys the database, I can modify the security groups if I want to like allow access from more than just my IP. If you wanted to add another IP there, you could modify the security group it gets launched with. You also can pull the publicly routable database name from here. Let's go to instances. So it's still creating, so it's not going to give me a publicly routable database name, but if I go to my other test database, there it is. So this endpoint, you plug into SQL Workbench or whatever you use to connect to SQL. Remember your username and password that you punched in, and you can log into it and query it. There's nothing in this one, but so that's how simple it is to deploy a basic SQL database. Again, any of those SQL options are available. Yeah. Any questions about RDS specifically in the service? All right, EC2. We talked a lot about EC2, so I'm not going to go into it too much because I'm going to deploy something in a second. But it's virtual servers, Windows and Linux. You can put load balancers in front of them using elastic load balancing. I'll talk about that again in a second. And they're deployed from these AMIs, or Amazon Machine Images. And I'm going to talk a little bit in a second about the AMI marketplace, which is a bunch of third-party and vendors who've put images into AWS for you to deploy with pre-configured software and stuff on them. Yeah, so basically if I go to the AWS account that I was just in, and I go to the EC2 service, and I go to running instances, and I click launch, and I go to the AWS Marketplace tab. I don't know if anyone has a particular piece of software application they were interested in deploying or installing on something, but if you search for it here, like say I search for, I don't know, RStudio, which is what we're going to look at in a second. There's all kinds of RStudio configurations that can be deployed ready-made for you. So you can deploy RStudio with TensorFlow GPU for AWS. It tells you what it's going to cost you up here. It tells you how to access it via your web browser. It tells you which packages are going to be installed, and that it's optimized to work with GPU. So if I selected this, I would go back to, well, they're show me a price list, so I know what things are going to cost. So you can see it's going to only deploy on GPU instance types, and it's going to cost money. There's community resources, so it's been rated. There's a bunch of usage instructions in terms of how to connect to it if I wanted to deploy it and use TensorFlow. And yeah, it's, but if I click create, I get my normal list of instance types, but it's only limited to GPU types. And then I can go and configure deployment. So that's configure all the deployment things that I would normally configure. So that's the AWS Marketplace. I would say that's a really good resource for people in the data sciences that want to deploy things, because if I go here and like search for data, big data, say, just some keyword, I'll get various tools pertaining to big data. If I search for, Tableau, I can deploy a Tableau server with Tableau already installed, an Attunity server. Yeah. If I type in like high performance computing,
You have to have licenses.
yeah, It'll give me options for all kinds of different types of servers. These will all be a little bit more expensive than regular services because if it's a licensed piece of software, it will charge you for the license. So if I go back to RStudio, you'll see that the first one that came up is RStudio Pro for AWS, and they charge you for the license, so 14 grand a year if you deploy that. So that's something to be aware of with some of these. They'll definitely let you know when you go to launch it that you'll be charged for a licensing fee, but again, make sure you keep track of your costs. Anyway, AWS Marketplace is a good tool. There's community AMIs as well. These are basically these are open source APIs that somebody somewhere created and published to the AWS Marketplace. AWS has a very low standard for letting them in, so they're not always great. The marketplace is where you get the stuff that's built by like official organizations and stamp of approval given by AWS. So if there is a service that you want deployed, I would recommend checking the AWS Marketplace. You can deploy a server of almost any kind pretty quickly from there. That's what the power of sort of these Amazon machine images. I guess another thing to mention is that if you create a server that you want to redeploy later on, and you want to make an image of it, you can do that very easily through the console. So if I wanted to redeploy this Windows tool server or move it from this region to another region, I could just click on it, click Create Image, and it would give me the option to create an image of that server. And then I have that image that I built, so I know what it looks like inside. I can redeploy it again in another region. I can share it with another account even. You can do all kinds of things once you have an AMI of a system that you've built and you like.
Quick question, Ira. So when you make an AMI, is that going to incur recurring monthly costs?
There's a small cost for AMIs because they use storage. They have to be stored somewhere, and they sit there sort of idle, but still costing something. That's another big thing to mention about instances. There is a very big cost difference between a running instance. So I go to the instance, you see all these are running. There's a big difference between a running instance and a stopped instance in terms of cost. So if I stop an instance, that's going to cost less than if I leave it running. So if you don't want to completely get rid of your instance, so there's 3 different states an instance can be in. It can be stopped, it can be started, or it can be terminated. If you terminate an instance, it goes away. It's gone forever. It's like throwing the computer in the garbage. If you stop an instance, it just shuts it down, basically. So, and stopping instances can also be a way of saving money if you're not comfortable getting rid of it completely. So, just FYI about instances. Any questions about the AWS Marketplace? It's just really something to be aware of if you're worried about the complexity of configuring your own stuff in AWS and then having to tear it down because it gets too expensive or something. Amazon S3. S3 is probably something that most people have heard of. I think it's probably the most widely used service in AWS. It's basically just generic storage as a service. So if I go to the S3 console here, you'll see kind of what that looks like. S3 uses the concept of a bucket. A lot of these are weirdly named because I needed unique IDs when I was doing automation earlier, but you can name them normal things. If I go to create a bucket and I say, and I name it something, the one thing about S3 buckets is every S3 bucket name is unique in the entire AWS universe. So try and pick unique names to name your S3 buckets, because if somebody else has one named the same thing as you, it will not let you create the bucket, basically. So every S3 bucket in AWS has to have a unique name, not just in your account either. So if I click next, there's a bunch of options here to keep versioning. I can put versioning on a bucket. I can put some tags on a bucket to use it for automation later on if I wanted. I can encrypt the objects in the bucket. So if I select this, I can encrypt it using one of 2 encryption keys if that's something that's important to you. It's good to know that it's there. I click next. Here's permissions. So by default, when you create a bucket, only the owner account, so only the account that I'm currently in has permissions. But it is good to know that you can make a bucket public if you want. It's not a good idea. AWS recommends against it, but you can publish a bucket out to the internet so that people can grab stuff from it. If you wanted to put stuff out on the public internet.
Quick note on that: if you guys keep up with any of those data breaches that are hit the news every once in a while, there's been a lot of them, especially lately, that I read about, and it says, "Oh, someone misconfigured their S3 bucket and made it public." So if you got to have a good reason to do this, please, and don't publish. When you publish a bucket as public, everything inside is accessible via the internet. So if you have data that is not something that you can share or want to share publicly, don't do that.
Yeah, AWS recommends against making any bucket public, though they provide the option to do it. They obviously recommend putting public information at a different place or hosting it some other way. So yeah, I can go ahead and create the bucket. It'll just create a storage location for me that I can then access, via this interface. I can actually just upload, whatever files to it. And then it's a storage location. There's a bunch of different tools that interface with S3 buckets. The one I really like, because it does a lot of different things, is Cloudberry, which is this. It basically allows you to browse S3 buckets through this interface. I can also transfer easily stuff from like my system to S3 buckets. And copy stuff up between my local system and the S3 bucket. It's just a little bit nicer than the S3 interface. Cloudberry also offers another product that allows you to automate your backups. So you could back up your local system drive to S3 using Cloudberry. Yeah, Cloudberry is a good tool. I recommend it for S3 connectivity. Yeah.
Is there pricing? I seem to recall if their pricing differs which direction the data is going.
Yeah.
There was a price for fetching the data that was different from the price for pushing it up, and same with performance.
Yeah. So to put data into S3 is free. To pull data out of S3 incurs a cost depending on the amount of data you're pulling out. As a university institution, we get a substantial discount on that cost, on egress costs. But yeah, that's an important note, that as you put information into the cloud, into S3, if it's information you're going to need to take back out for any reason, make sure you realize that you may have to pay to get it back out.
Quick addition to that. So when Ira mentions that as university participants, we get a discount on data egress, you actually have to go through and fill out the form on the IT catalog. And we're going to demo that later, but just know that you don't just get it automatically. You have to actually fill out a form on the IT catalog to get that discount.
Maybe I'm a designer, but when you do that type of storage through the university, can we assume it's forever? In other words, will the university ever, if I put 100 terabytes up there, it would suck if the university said, we're switching to someone else, because it would take forever to move it, you know what I mean? What kind of long-term storage, if I want to use it for archival storage?
Right, so that's a good question. Don't forget that these resources that you sign up for are under your own dominion. So the university is not doing anything on your behalf necessarily. It's handling all the high-level negotiations to be able to bring some discounts to you. But as the owner of the account and as the owner of the data, you are responsible for doing that. So the university is not footing the bill. It's just negotiated a discount for you and your department to be able to handle those costs. If you decide to move it somewhere, it would be beholden to you to update any links or handle any costs with your unit or department.
But okay, so do I know when I put the data up there what it's going to cost me to get it off? It sounds like the answer is no. It could change if the university changes its deal with Amazon. The price might go up significantly to fetch that data.
Oh, so Yeah, that's a good question. I don't foresee the negotiation ever backing out. I mean, we've had this in place for a few years now, so I don't foresee the price changing. It used to be more, now it's less, and as long as nobody has a cow about that, it should stay that way.
Time in general, just because of the natural trend in technology.
Shoulds are great, but archival storage is someone who has data they want to keep forever. I mean, you know, this isn't a real serious use case, but if there's a choice to be made between a spinning drive and a lab that can touch it, and something on the cloud, which, gosh, 20 years from now, someone, hey, I need that data set. How much is it going to cost me to fetch? You know what I mean?
Yeah. That's.
It's good to like just note what these costs are too in a practical sense. So for data that needs to be archived for a long period of time, right? Amazon Glacier is like a storage system that doesn't allow ready access to the data, but allows you to request the archive out of AWS. So you won't be able to just access files as needed like I was doing here, but you will be able to get to them when you need them. That's it's what, like yeah, it takes a long time to get it out, but it's it's like 4/20ths of a cent or whatever per gigabyte, so it's really cheap. And then data egress costs are also pretty cheap. Yeah, the request costs here are 5 cents per 1,000 requests. So that's for requests into Glacier to pull data out.
That to add on to that, that's a good question about like how you're going to set up your data, your stance on data retrieval and archiving. You can do it the bad way and have it be more expensive depending on your needs. So, for your use case that you talked about, if it's data that I want to keep for 20 years that I may reference one time in the future, there's a way you can architect your system in order to have the best cost savings around that. If you need it to be available on demand or all those things, there may be a different stance that you can do. IET can help talk with you about those ins and outs. So, we're available to sort of meet offline about that.
Yeah.
Maybe you can talk to your local IT. We'll set up you're a college engineer, okay. But I'm saying most departments have somebody that knows about it.
Yeah, it was me when I set up. So, But no, I was curious. We chose against Amazon for that reason.
Because of egress costs or transfer costs.
Quicker access.
Right.
And the cost, and we didn't want to use Glacier cost.
Yeah, there are other actual cloud vendors that have similar products but different cost structures. So that's part of what, at the university we want to look at and provide sort of the best use case for folks. This talk in particular is about Amazon, but I know Google Cloud has an offering. We're still working through getting a BAA with Google on this. So technically we're not supposed to use it, but this is stuff that we're looking at separately because at the university, we're not beholden to any particular group. This is an Amazon talk because there's a lot of, they're an industry leader. There's a lot of expertise around it. They're, well established, but they're not necessarily the only game in town. So we're, keeping an eye on the horizon for that.
Yeah.
Quick following up question. When folks are approaching you or asking about Amazon or other cloud computing, what are they most wanting to do? Is it this archival monthly storage, or is it these shorter term spin-up analysis projects? Or is that partly why you're here today, because you want to get that landscape and find it?
Yeah, I think so. So, I mean, my personal experience before working at IET, I was working for the Bioinformatics Core when it was run by Dr. Lin, and we were pretty savvy when it came to Amazon and what it can do for us. So that was more on the research, genomics data pipeline, that sort of thing. In central IT, we use it for more administrative uses, and a lot of departments have that idea. They mirror that. I think one of the best things about this intercommunication between IET and the Data Science Institute is that we can bring some of this expertise to you guys, and you can help us sort of, guide our roadmap to include more data science projects. That's something that at the university I think is a very big use case and a very useful thing that we can do for you guys, with you guys, really. So, yeah. Did that answer your question?
So yeah, S3 is a good service, but there are like those considerations like we talked about. So it's something that if you're going to use it for storing a lot of data, definitely talk to an IT person and get a sense of what the costs are going to be and what the trade-offs are. Okay, I'm going to quickly move on to talk about Cloud Formation. So I have a demo to sort of talk about what Cloud Formation does and is, and I'm just going to get into that or get that started so I can sort of talk while it's happening. So like I said before, Cloud Formation is basically an AWS service that allows you to deploy all of the other AWS services. It's really a software packaging or automation tool. It allows you to deploy what we call Cloud Formation templates. They look like this. Wrong one. Well, yeah, we can pull this up. So right now, the one that I'm going to deploy here is hosted in a Bitbucket repository that we own, and we're going to share out to folks via our cloud at ucdavis.edu website. It's this RStudio Shiny server deployment template. So it looks intimidating, but it's easy to deploy. So that's what I'm going to demo now, and I'll deploy it, and then I'll talk a little bit about what is in the template. So to deploy, it's really easy. So if I've cloned that repo or just downloaded the file from Bitbucket or whatever you guys are comfortable with, and I want to create the RStudio and Shiny server, I click Create Stack. I can choose file and just browse to it on my system. It's in a directory on my system under Git. So I've just cloned the repository here. There's a README that describes these steps for doing this in the repo as well. I click Open. It loads it. Click Next, and it'll ask me to populate some field information. So this is all programmed into the template. So I give the stack that I want to deploy a name. The desired root volume size, so this is just the size of the volume that I want to put behind it. I'll say 200 gigs in case you guys are trying to crunch a lot of data. I configure an initial password for the service and an initial username. I'll just give it my username. I'm going to deploy a T2 micro just because that's easy. And then it asks for my external IP. So the way I usually get my external IP is by going to whatismyip.com. That tells me what my IP is. I copy it out and copy it in. And this is to configure the security group configuration for when this is deployed. There's not a good way using Cloud Formation to fetch that. Server type, I selected RStudio. In the future, either this template or another template may support other things like extra packages, RStudio with certain packages, or Jupyter Notebooks or something like that. Jupyter Notebooks is really hard to automate the deployment of, I realized. So I'll give it a tag, just so that tag basically just gets applied to everything that's deployed as the name of the thing. So it'll be the name of my server, etc. Go ahead and click Next. Acknowledge the acknowledgements, and then you'll see it's creating in progress. So I can see the things it's doing down here. It's creating an S3 bucket. It created an IAM role. It's creating an internet gateway. This is sort of all going to be abstracted. And at the end of the day, what I'm going to get in this output section is just 2 strings, one to connect to the Shiny server, one to connect to our Studio, and 3 strings, and one to connect the S3 bucket if I need to. So yeah, so that's Cloud Formation. And that's kind of what it does. So once it deploys things, I'll just go into what it's actually deploying to. So it's if I look at like the EC2 console right now, what I should be able to see is soon an instance will pop up here once it gets to the point where it's deploying the actual EC2 instance. Right now it's setting up some routing and other network configurations, but eventually we'll be able to see the instance coming up. So basically all of this stuff, the network routes, the S3 bucket, etc., is contained within this text file. So this text file tells it exactly how to deploy and configure everything, including down to the instance deployment, which is spec'd in here to deploy the instance, and then run some commands at startup. So you can even do that when you're deploying EC2 instances. There's this concept of user data where you can pass commands into the instance to run at startup. So that's what it's doing. That's how it's configuring the Shiny server and RStudio. The CloudFormation is broken into resource blocks. So there's a lot of documentation online about how to use CloudFormation. I'm not going to get too far into it because it's a little bit detailed, but one of the things that we want to do in IET is to engage more with the research community, is create more of this sort of packaged infrastructure. There's a lot of this stuff already out there for you guys is the other thing. So if I just Google what Amazon calls them is quick starts. If I just go to Amazon quick starts, what you'll find is like a huge variety of options for deploying various types of infrastructures. So if I just go to like big data and analytics, let's say. So like a lot of the top vendors will contribute architectures that they think are helpful in deploying big data. If I click on one, I don't know if anyone has a preference, the AWS time series data connector, right? It will basically stand up an architecture that looks like this. So it describes sort of, the quick start guide will describe what the architecture looks like, all of the services that'll get deployed for you, and how to use the CloudFormation template. And you normally are able to easily just follow some basic instructions for deploying the templates, the quick start templates. So some of them are more complicated than others, but by and large, they're pretty simple to deploy. Yeah, so you know, some of them have kind of complicated deployment guides, but they'll usually be like a pretty straightforward deployment. So if you have like a database that you want to deploy, yeah. So there's a bunch of services here as quick start guides that AWS will basically provide you with a CloudFormation template to deploy the service. So yeah, and they'll describe the architecture to you in detail, that kind of stuff. So this is different from AMI's because it's deploying a bunch of different services, and it's basically all done in the same way as what I just did with that CloudFormation template. The difference is mine just deployed on our Studio server, which we can see standing up now. Yeah, so that's like automated deployments in AWS using CloudFormation. Once the server stands up, I'll log into it and you can see it's functioning. Are there any questions about CloudFormation or quick start guides in general, or quick start deployments?
I know that seemed very fast, but he just stood up an environment that you guys can use for your data in the span of 5 minutes.
Well,
so
it's still standing up. Yeah, it takes a little while to do all the deployment components, but you know, a couple more minutes and then they'll be in our server. What it's going to deploy is basically an environment that looks like this. So it's going to deploy an EC2 instance running RStudio and Shiny. It's going to deploy an application load balancer so that I can connect to the web page, the web interface for the instance via HTTP. it's going to connect that server to an S3 bucket that I can use to upload large files and other things to get access and expand my storage volume. So instead of having to store everything on the server, I can store it in S3 and copy it out of S3 onto the instance. And basically, it'll deploy all of the networking necessary for the VPC and AWS. And like I said, there is a ton of these like resources out there. This is a very simple one that we were able to mock up here, specific to some use cases that we thought about. But there are much larger architectures that can be deployed this way as well. I'll just check on it. All right, so it says create complete, so that means it's done. And the output of this operation is basically 2 front-end URLs, one for the RStudio server, one for Shiny. If I browse to them, it's possible they're working now, though they may not be. Yeah, RStudio is working, so I log in with the password, username and password that I gave it before, maybe. If Shiny's not working yet, then it's just not finishing up the deployment. Yeah. Mm-hmm. Mm-hmm. Let's check on the load balancers here. I think I must have deployed an old one, or something else. Anyway, if I copy this code out, which is got to be the correct code, I can deploy it via Cloud Formation again. I'll just set it up and deploy it and move on, and then come back to it. Because this one isn't working. Just delete it. Okay, so I'm going to deploy it and just move on via a separate route because I think that one was an old template from a different repo, not the one online, unfortunately, because I did it a different way. I grabbed it from the wrong file. Anyway, sorry about that. Okay, so that's Cloud Formation. While I'm doing this, does anyone have questions besides why didn't it work? Okay. All right. Okay, so that's Cloud Formation. I'm going to talk a little bit about advanced services, and I have a quick demo that will work, I'm pretty sure, because it's manual later on. So once I talk about these services, I'll get to that. Lambda is an Amazon Web Services like code execution environment. So this is a place where you can execute Python code without having to manage the underlying server infrastructure. So the interface looks fairly simple. It's basically just let's see. So basically, you just create your function. You can use Python to create a function and run Python, Node.js, Java, Go, .NET, various other programming languages. You can write a function and hook it up to other AWS services or an API gateway. And that will allow you to basically execute code from AWS directly without having to deal with the underlying infrastructure, managed servers, etc. Typically, we use this in IET for like automating simple tasks like backing up EBS volumes or creating a simple API gateway to do like a basic calculation or respond to a request. But it can be used, for various data ingest purposes. So if you need to stream data into your account, you can set up a Python script that will allow you to do that. Yeah, I know there's a lot of apps that have been built on top of Lambda to do various things. One of the other advanced services is AWS Glue. So I'm going to do a quick demo on this while the other one wraps up, and I'm going to talk about basically AWS Glue is an ETL service. So it's a data ingestion and schema creation service. So basically, it takes information that you put in an S3 bucket and it reads it into a schema that you can then query using like Athena or Redshift to do like SQL queries against it. So to just demonstrate what that looks like, I'm going to go to my S3 console here and upload some data.
Quick acronym check. Do you guys know what ETL stands for? Extract, transform, load. It's really an acronym that tells you exactly what the class of software does. All it does is, you can kind of guess from the name Amazon, AWS Glue, that it is sort of the glue between data and processing that data. So you extract data from somewhere, you transform it, digest it somehow, and then you put it somewhere else. You can imagine this can be used in a variety of ways to clean up your data before you put it through your analysis or whatever.
Yeah. So what I'm going to demo today is it working against a relatively simple file. So I have on my desktop this just a file of a CVS file that contains a lot of basketball statistics basically for all the players in the NBA right now. It's a standard CSV comma delimited file with the columns sort of comma delimited and common format with a header row and everything. So what I can do with AWS Glue is I can take that file and upload it to an S3 bucket here. And so the file's now in an S3 bucket, and if I go to the Amazon Glue console, AWS Glue here, one of the things I can do is add a table. I can add a table using what's called a crawler. And the crawler will look through the data in an S3 bucket and create a schema based on that. So I'm going to call this MBA stats. I'm going to go next. I'll choose an S3 bucket. The one I loaded it into is called IRA test S3 bucket. Iris test demo S3 bucket. All right. I'm just going to copy it from here. Anyway, I grab the name of the bucket. I go to the AWS Glue console. I paste it in with some language telling it that it's an S3 bucket. I tell it, I go ahead and create an IAM store for my MBA crawler. So I've given an S3 bucket. I can run it on demand. I'm going to create a new database called MBA stats based on the CSV data, and click finish. And what it'll do is it'll crawl through that CSV and create a schema. Again, CSV is like sort of the coward's way out here, but the glue tool can also allow you to create custom classifiers. So if your unstructured data has different delimiters, or is JSON data, or has different fields that you want to extract into a schema, you can specify that as a grok pattern here. You can also specify it as a custom pattern underneath, and you can run custom classifiers over S3 data. So if you have files that you're uploading to S3 and you like to put them into a database and they're unstructured, but you want to be able to query them, you can do that via this this glue application, this glue tool. So if I go back to my crawlers, I'll click on this one and I'll run the crawler. And basically that's going to run over that data and create a schema for me. This works well with another service which is called Athena. So Athena allows you to put a query language over the top of an S3 object. So if I've imported the CSV into Glue and now I have an S3 object, now I can if I go to the Athena console, what I can do is connect that Athena tool to the Glue database that's being created, and I can go ahead and query that data. So I can also create the crawler again here. I can create a new crawler.
I think you knocked out a letter there.
I'll create a new database again for this, just called MBA2. Whatever. Okay, so then this crawler, if I run it, what I can do is if I go back to the Athena console and refresh, I should see a couple different databases here, including the MBA stats database, and you'll see that the Glue application has created a schema for me. So if I go here, I can preview the table, and that'll run basically just a standard SQL query against the table and give me the data out of that CSV file here, which I can then use standard SQL queries to run to manipulate and augment the data, and that's just unstructured data sitting in S3 that I ran a glue crawler over to create a schema, and then I ran Athena to hook it up to a SQL querying language, which I can then use to manipulate it. So I don't even need a database in this case. I just needed an S3 bucket. I needed to create a crawler in Glue to crawl over the data, and then I needed to use Athena to connect to the data store that crawler created to query it using SQL. Yeah, and then
so I guess the utility of this particular process is probably going to come down to the power crawler.
Yeah, so the crawler is incredibly customizable, which is a nice thing. So you basically can control how powerful the crawler is by providing it with like patterns to look up within your data to create the schemas. So you can specify, you know, well, first of all, there's built-in crawler types to do VPC flow log, data ingestion, and other things. But there's also pattern matching that it'll do. So if you had a particular pattern in your data that you wanted to pull out into a schema, you could specify it via grok pattern here. You can also
Is grok different from regular expressions?
yeah, slightly. There's a so AWS has its own set of documentation on Glue and Grok query languages. It has a good document on writing custom classifiers. So it sort of will explain what the pattern matching syntax looks like and how you can create those expressions to query through the S3 data. But it's incredibly customizable. So if what you're looking to do is make sense of raw data in S3, then using Glue is like a really good resource to do that. So yeah, it's definitely comes down to how powerful the crawler is, but the crawler works on a lot of sort of standard formatted text. So you can do it over XML or over JSON, or like I did over CSV as well. Yeah. Okay. So my Cloud Formation template finally deployed with an RStudio server. So now basically what I think happened was I got some old code, but now this is what was pulled directly from the repo. So I have my two front-end URLs, the RStudio server and Shiny. And if I copy and if I go to the Outputs tab of the Cloud Formation section, I can copy the RStudio server web URL and paste it in here. And it takes me to the RStudio front end. And again, I just logged in using the credentials I created up front. And I can now, you know, do things like look at like all of the sort of standard data sets within within R. And I could pull in data and install packages from this package manager. I also have access to a terminal, and the account that is provisioned has root access. So I can drop down to root and make changes, install packages in the terminal here. I can also deploy, like, I have a Shiny example app, which I can deploy into the console as well and use Shiny. Use the sort of web application, deploy a Shiny app if I wanted, say. Hopefully this works. No. Yeah, so this is just a Shiny app that basically ingests a bunch of the regular data sets and allows me to browse through them. So if you're not, how many people are familiar with Shiny? I guess most everyone in here, yeah. So it's an R utility that allows you to make reactive UIs and graphical interfaces. So this server has both Shiny and R installed. You can import apps into Shiny. You can browse through the file system here. So if I go back to my terminal window, you can see that I'm in my home directory, which hosts an S3 and a S3 bucket location. So right now that S3 bucket doesn't have anything in it, but if I go back to the Cloud Formation template, let's see, which is this one, and I go to the output section, I can see the name of that S3 bucket, which is nice and long to make it unique. And if I go to the S3 section of the interface, I can go to that bucket and upload. I can just upload that same CSV file I had before. And then if I go back to my RShiny or RStudio web interface, it should show up, but it's not. Anyway, I won't futz with it too much more. This S3 mount, I guess whatever the problem is with it, I will fix, and then it should allow you to import objects into the system via S3, but obviously you could also just upload them in the normal fashion through the RStudio interface. No. Well, I don't have permission on that folder. Yeah, and then obviously do various commands on your data once you load it that way. Yeah. I'd probably have to load it into a data frame. Oh, yeah. Anyway, so that, you guys obviously probably definitely know how to use R better than I do, but that is a package deployment via Cloud Formation. I made it look very complicated, but it's actually not. It's just a matter of uploading that file, filling out the fields, and running the Cloud Formation template. It'll spit out these outputs here, and then you'll be able to log into both your Shiny and RStudio front-end services, as well as get an S3 bucket, which should be mounted to your RStudio server so that you can upload files via S3 there. Anyway, that's it. It also, this is a service we're looking to expand. Obviously, this is not a good illustration of how it'll work in the future, but we're hoping to get much better sort of tools out there for you guys to quickly deploy things to AWS, things you might want to try. But there's already a large number of things out in the community as well. So I just wanted to come back to that. Are there questions on either, besides the obvious questions on either the Glue and Athena or Cloud Formation and the RStudio server? Yeah.
For the RStudio server, do you have to do it this way where you're making both an EC2 instance and an S3? I assume you're paying for both simultaneously.
No. So you could leave out the S3, and if that's preferred, the S3 bucket was really designed basically to save on storage. So if you didn't want to keep everything on EBS volume, so instances by default come with storage in the background, right? A hard disk, and that EBS volume is more expensive than S3, basically. So elastic block store volumes tend to be much more expensive than S3 per gigabyte. So sometimes, because there are tools to map an S3 drive to the file system, evidence to the contrary notwithstanding, you can use S3 as a storage location for your big data files and copy them into a server from that mounted file location as needed only. But if that's not something you want, or that's not needed, we can, an option could easily be added to the Cloud Formation template to not deploy the S3 server.
So to expand on that a little bit, it's more of a philosophical question. When I used to show folks that attended the bioinformatics short course how to set themselves up on Amazon Web Services to do their analysis, one thing that I impressed upon them is try to keep your data and the machine that's doing the processing separate, because that way you have flexibility on changing the machine out in order to do your analysis. In other words, this Cloud Formation template just launched a small server with RStudio, and because it launched a small EC2 instance, it has its own elastic block storage. You can separate that block storage out and make it its own volume, and then you'd be paying for essentially renting a hard drive. So if you have an 8 gigabyte storage volume, you're paying for all 8 gigs, whether there's 100 megs of data on there or 5 gigs of data on there, you're paying for all 8. One of the advantages of S3 is that you're only paying for the space that you're using. Not only that, it is a lot more durable than EBS for one, and also it is separated out so that you can run other analysis on the same data should you choose to. One of the drawbacks of EBS is that it can only be mounted on one machine at a time. I think they've changed that lately. I think they've relaxed that, but it used to be that case at least, where you can only mount it on one machine at a time, which makes it tough if you want to run multiple analysis pipelines on the same data set. In other words, that's one of the benefits, one of the paradigm shifts in your mind about using cloud computing to help you with your science. The fact that you can run an analysis using 5 pipelines at once if you want. Find out which one finishes first, which one was cheapest. You can do that. And then that could be the pipeline that you publish in your paper. So the fact that you can store the data separately gives you a lot of flexibility. So that's one of the reasons you'd want to use S3 or a persistent data store that you only pay for what you use.
The other reason is, I know I sort of mumbled through it, but you can do things like put other services in front of S3 to make them available to people who aren't on your server. So EBS block storage, because it's the hard disk of your server, is only accessible when people get on the server themselves. With RStudio, it's a little different because you have the ability to upload through a browser to the server server storage itself, but and it's a front-end app for you. But if you, say, wanted to have a contributor at another university not have access to your RStudio instance, but you wanted them to give you some data through a different means, you could set up that S3 bucket as essentially an SFTP like endpoint for them to transfer data and files into, and then you could grab them out of that bucket from the instance and run them within your R environment. So that's also another advantage of S3, is it's accessible outside the context of that one server. And then in one of the other points is, elastic block storage is locked down. So one elastic block storage volume is it's a one-to-one relationship between an instance and an elastic block storage volume, but there's another service called EFS, which allows you to connect one storage volume to multiple servers if you want to. So that's something to be aware of.
There's a question here.
Yeah.
Somewhat dumb question. So earlier you introduced Marketplace.
Yeah.
And I saw a few RStudio options over there. How is that different from installing our own RStudio?
The major difference between that and this is those ones, one of them charges you a licensing fee, and this is the community version of RStudio. The other difference is that this one, those ones are packaged and distributed, and they're solid state. They can't be adjusted, and they can't include other infrastructure. With this Cloud Formation template, if there was feedback that it was desired that we deploy a database with it, say attach a PostgreSQL database to this when it deploys, we could implement that in Cloud Formation. Or and then the other thing about this is those services don't deploy. They don't deploy Shiny alongside RStudio in all cases, and this could be customized, to do various things for you, including mounts an S3 volume or connect to other services within AWS. So it's a broader infrastructure deployment rather than just a single server.
That said, I mean, the marketplace, the reason we shared the marketplace is so that you guys can check out what is available there and spin it up and see what is useful to you there. Mm-hmm. If you find that there's something in the community, you've come to rely on the Cloud Formation templates that IET has available for everybody, but you're finding something in the marketplace that you think would be beneficial to yourself and others, it could be a conversation to have us, throw it into that template and improve it. The ones on the marketplace, like Ira said, are provided by a third party, and there's no dialogue there as to whether one wants to improve it or not. The ones that we have at UC Davis is something that we can have a dialogue about and improve that way and version it.
Yeah, and Cloud Formation is a tool that we'll be using for a lot of things within IET and currently use for a lot of automation within IET. So it's that particular Bitbucket repo, which is going to be hosted on our cloud website. That's something that you'll be able to sort of access and see like new things getting posted to as we develop them, and also provide direct feedback to us about them. Before we move on to just like prices and stuff, because we have to get through this kind of quickly, I wanted to just talk about some of the other, I just wanted to give you a sample of what are the other services that exist for big data and data analytics in general. So there's a ton of machine learning services. There's SageMaker, Deep Lens, which is, SageMaker's a machine learning algorithm service, so you can upload your machine learning algorithms and your test data sets or your learning sets and run them through SageMaker to create, basically machine learning components and use it as a machine learning service. Deep Lens is the first sort of graphical machine learning service. So if that's something that's useful to you, Amazon sells a camera that you can use to teach Deep Lens to recognize faces and do other things. So it's kind of creepy. Amazon Lex is a voice activated, is a lexicon service. So you can teach it to recognize human speech and speech patterns. And Polly is the other side of that. So it's the service that you can teach to speak human understandable speech. AWS Neptune is a graph database. AWS DynamoDB is the NoSQL database as a service. And AWS QuickSight is kind of like Tableau. It's like a data visualization tool. You can hook it up to any data service databases and use it to sort of visualize that data in graphs and other things. And now, I'm just going to move on to managing costs in AWS. But if there are any questions about specific services, reach out to Jose or myself afterwards, and we can have a one-on-one conversation about that offline. So paying for AWS, AWS bills on a monthly basis. So we talked about that kind of. It bills mostly for runtime per hour and amount of sort of resource utilized. The most expensive resources in AWS tend to be the ones that you'll probably use the most. RDS, DynamoDB, EC2, Redshift, Elasticsearch are some of the really expensive services. AWS provides some good tools for predicting costs, though. So the AWS Cost Calculator is a tool that anyone has access to, and it basically allows you to spec out the infrastructure you're thinking about deploying and determine what it costs. So rather than going through all the different AWS cost and billing spreadsheets and figuring out how much things are going to cost by adding them up together, you can just design your infrastructure here, basically. And AWS will calculate the costs on this spreadsheet for you. So it'll tell you what your monthly bill is going to be. And it'll predict the cost for your monthly runtime, basically. If I added an EC2 C4 X large instance, and it says it's going to cost $73 a month. So that's a quick and easy way to calculate a large set of infrastructure if you're thinking about deploying it to AWS beforehand. In the account, the AWS Cost Explorer provides you with some predictive analytics about what your bill is going to be for that month based on what your current usage is and what your past usage has been. And it allows you to develop sort of customized reports about what your bills will look like. So it's a nice tool for figuring out how much your AWS account is going to cost. So in this case, it's predicting My cost will be $40 a month because they were 19 last month, $5 this month, but I've been using a lot of resources today. So there are a lot of tools within the AWS account to do that. And I got here just by going to up in this, clicking on the account name and going to my account, and it takes you to the billing center, which allows you to do all that stuff. And you can look at the dashboard to get a quick summary of what your bill is and what it's going to be. All right. This is like what a bill looks like. So it just breaks it down for how much things cost. It tells you how many hours you ran a particular instance. So some of these you'll see, like this T2 Medium this month ran for 3,000 hours. That's because we have multiple of them deployed, basically. 3,000 hours of T2 Medium used that month. And you can see, like, if you deploy this is all of, 12 servers, probably. Some of them were not running for very long, a few hours. But it adds up pretty quickly because this bill's $3,000 basically just for EC2 usage. It'll also charge you for that EBS block storage. So that's something to be aware of too. For every gigabyte you add to a drive on one of the EC2 servers that you deploy, you're going to get charged a little bit for that. Free tier stuff. So I talked about free tier a little bit. This is what you get in the first 12 months of an AWS account. You get 750 hours of EC2, Linux, or Windows 2012 to 2016 on a T2 micro instance. So that's enough to run one instance for a year. But as we were talking about earlier, those small instances will sometimes, if you're running a high load on them, they'll burst above the memory utilization rate. And so you may get charged a few cents here and there on your account because your instance used more than its allotted memory or more than its allotted CPU. And they will charge you for that extra usage. You get 750 hours of elastic load balancing services. So you can put an elastic load balancer in front of your instances and you can keep it in place for 750 hours, which is a whole year. 30 gigabytes of elastic block storage for the year, 5 gigabytes of S3 standard, and 750 hours of RDS for MySQL Postgres or SQL Server on a DB2 micro instance, or Aurora is included here too. So that's for the first 12 months. Once you've been in AWS a year, you don't get any of this stuff anymore. But you always will get 25 gigs of DynamoDB and 3.2 million seconds of AWS Cloud Compute, and Amazon Glacier storage. You can store 10 gigabytes of retrieval a month for free. So retrieving data from Glacier, which is that long-term storage solution, is free for 10 gigs a month. More free stuff, educational credits. If you're not aware, you are, as members of a educational institution, entitled to some Amazon free credits. You apply through the AWS Educate program. So if you search for AWS Educate, it'll give you, you'll find a form to apply for free credits through this program. So basically you sign up with your institutional email address, you give them some basic information about yourself and your role at the university, and you apply for credits. For educators, it's $200 in credits per educator, $7,500 in AWS credits per educator at a non-member institution.
We are a member institution.
We are a member institution, yeah. We have a BAA. So, and then you also get free access to training, free access to labs, 50% off instructor-led training by AWS, a bunch of different services, basically, for free if you're an educator. And students also get, $100 in AWS credits. Yeah, a bunch of various training resources. It's something to look into if you're thinking about using AWS, the AWS Educate program. And there's links at the sort of end of this presentation to that.
Yeah, on cloud.ucdavis.edu, there's a resources tab, and we have thrown a bunch of links on there that will hopefully be helpful to you, including this one.
And there's a bunch of links here. There's various grant programs for AWS. AWS hosts a bunch of public data sets at the registry.opendata.aws.com. So Sentinel-2, Landsat 8, a bunch of sort of common data sets are hosted on S3. This webpage will show you how to get to those. And the AWS Big Data blog is a good resource for things that are going on in data at AWS. And we also have our own website here on campus, cloud.ucdavis.edu, which has a ton of different services to offer. Jose is going to tour that in 1 second. So yeah, these are just some helpful links to the AWS Marketplace, public data sets, HPC on AWS, and some quick starts, as well as the AWS Big Data blog and AWS Educate. Good practices we've kind of talked about. One thing to know about is the hashtag Cloud Computing Slack channel. That's a place where IET is very active, and there's a lot of smart people on there answering cloud computing questions. If you're going to get into cloud computing and you have questions, that's definitely something to check out. And then we have cloud.ucdavis.edu, which is our cloud website where we're going to be providing resources to the campus, as well as ways to onboard into AWS. So
I can talk a little bit
about that a little bit.
I'm not going to give you a tour of a website. You guys know how a website works. But some of the stuff that I did want to show you is one of the things to consider is data sensitivity. This is one of these questions that happens a lot at the university, like what you can store where. And this is a place where we've published that information. You can find it under services here. We have a host of services up here. Amazon is the first one, alphabetically. But you'll see there's a huge number of services that are available on campus for both researchers and administrative units. And one of the nice things is that what you can store in Amazon is talked about here. So you see you can't store every type of information on Amazon without getting proper permissions. What that looks like for you guys is important because you may have particular data sets. You may have HIPAA information, for instance, and you need to get specifically approved to store that stuff. But there is some stuff that's already been pre-approved for storage because that's what we're using it for, so that's interesting. The fact that the data types are also published here is really nice because you can find out more information on UC Davis's stance on these, like what they are. If you were to have asked me what sort of data types there are to store in the cloud, I wouldn't have known before. I have this handy list. We're looking to publish a bunch of case studies, and I think this is interesting. This is something that you guys can help us out with because the work that you're doing is very interesting, and when it becomes generally applicable, it's very interesting to have a way to publish those and share them with others. So we have a few on here that we've used, but these are really administrative, and we'd love to sort of beef up that with something more research-oriented as well. And finally, to share, the resources tab here has a list of all that stuff, including AWS Educate, research credits, and all that stuff. All the links in the presentation, I think, are up here as well, and we'll be changing this up. So that's the site.
Cool. Yeah, so there are resources available to you here at the university through IET. We can help in a number of ways. One, we're trying to really provide as a service to folks at the university because new security requirements are coming in from various places, and data providers and grant distributors are increasingly requiring certain levels of security around data and research environments. We're working on building secure environments within AWS where you have access to AWS services, but the security and the controls are taken care of by IT. So the first environment like this that we've built is the most stringent security environment that exists, that we probably will build in AWS, and that's the Secure Research Computing Environment, or SOURCE for short. It's there for hosting NIST 800-171 data type secure data, so CUI. If those kinds of data sensitivity levels are built into your grant contracts or your data providers are asking you to have that kind of security, we do have an environment in AWS that provides that type of security, and we're looking to expand the service set that's available within AWS. Right now it's highly managed, so we hold the keys and monitor everything. We ship your logs back to a centralized logging location, and really all you get access to is server environments at the moment. But because it's in AWS, there is movements to expand what those service offerings are beyond just having server environments available to you. Yeah, so this is kind of what that environment looks like. Basically, we have a management account and a security account where we have access to a number of different sub-accounts. You'll have access to one of these sub-accounts to deploy resources into, and we'll ship your logs and monitor your network activity and can restrict the network ingress and egress through your environment. So there's a lot of controls around the data that goes into these. If you don't need the environment, it's not something that's recommended that you look into. But if you do have data that you're working with in a research capacity that requires a NIST 800-171 security standard, or is controlled unclassified information, or just has a high level of security requirement around it, this is something to look at. If you email ietconsult@ucdavis.edu, you can get more information about it, and they'll forward you on to the team that manages it, which is currently me and a couple other folks. And we'll discuss with you and engage with you about whether this is the right fit or not. But this is available now, and it's a sort of a first stab at trying to provision security in the cloud for researchers that need it. We have a bunch of information and packaged architecture based on feedback from you. So I have a link to that Bitbucket repo that I pulled the Cloud Formation template, which will work from. So that's going to get populated with more data as time goes on and more feedback comes in from you guys. So it's something we're looking to expand. We have the IET Cloud Services website. You can request, IET is looking to handle invoice billing, and you can request to have your environment added to invoice billing through the IET Services catalog if you don't, if it's complicated for you to pay with a P card or a credit card. And the Cloud Services website is going to be updated on a regular basis with information about AWS, offers from AWS, and just generally information about how to get into the cloud. And hopefully will become sort of a one-stop shop for all things related to cloud services at UC Davis, at least in terms of as it pertains to IT resources. So yeah, this is what Jose kind of talked about. This is hosted on the cloud.ucdavis.edu website, but this is just a list of all the data that can currently be stored in AWS. I won't go through it because we're low on time here, but basically de-identified and anonymized data is fine. If you're working with anything that has security controls around it or is very sensitive PII data, you should seek guidance from cybersecurity at ucdavis.edu or IET Consult at ucdavis.edu if you think your data meets a high security data sensitivity requirement. We have a service, we're looking to launch IET Cloud Services Brokerage, which is a service that basically where IET will handle your billing for you. We have a few different initiatives around this, but we will be offering this as a service. So if you don't have a P card, you can't open an account yourself, you have an account string from your department, and you want IET to handle that billing for you, we are introducing a service to do that.
I can talk a little bit more about it if
that,
you want.
Yeah. Sure. And Jose's got some more information around that.
So I know the hour is waning. We managed to fill up the 3 hours. Thank you for sticking with us. I want to talk about a couple things. One is, how do you get set up for AWS on campus? We can all sign up with, separately. You sign up through AWS, you have your AWS account number. But I wanted to bring first to mind that there's a form that you can fill out to, put it through the official channels and join the UC Davis BAA, the UC-wide actually BAA, and that has a bunch of benefits for you. One of the things that Ira mentioned that we're working on is a way to broker some of these cloud products for campus. It can be a infrastructure like Amazon Web Services, which is what we're talking about here, but it extends beyond that. Part of what we're doing is trying to provide value for the campus, and we're doing that in 4 key areas. We're doing it in the billing provisioning, which is something that we're setting up right now, so that paying for AWS is proven rather difficult for groups, even if you have your PI approval. One of the things that I'm finding is that there's a lot of continuity of service interruptions because bills don't get paid because somebody's purchasing administrator has retired and they never bothered to pay the bills and things like that. There's a number of AWS credits, like data egress credits, that are never getting applied for some reason to the accounts. There's a lot of issues with having an account yourself and having your department handle the paying for it. So this is one of the services that we can provide. We're finding a lot of issues with security as well. I mean, we had this conversation about security and talked about IAM roles and your security groups and things like that. This is very esoteric stuff that as researchers, really, we would love for you guys to be doing the research, and some of this stuff like security and role administration should be abstracted from you so that it gets out of your way so that you can keep doing your work. So that's another thing that we're doing as far as brokering that for you. The reference architecture that we showed you today, the Cloud Formation that finally worked, is part of an initiative where we're publishing it for all the campus. As far as reference architecture for AWS in particular, that's part of this initiative as well. And that is really collaboration with you all, with colleges and stuff. We want to, just bring it all to the table for all of us to share in. So that's part of this. And finally, trying to enable conversation around it, because we're providing the help we can, but IET are not the only people who do this. In fact, there's a lot of smart people on campus who are doing really interesting stuff with AWS Cloud and Cloud in general, and those people should be able to speak together. The Cloud Computing Slack channel, again, that's linked to on cloud.ucdavis.edu, is part of that initiative, and we're trying to get conversation going around that. So when you have questions, you don't have to wait for a particular group to be able to get answers to you. You can ask each other and ask other people who have an interest in this route. The last thing I wanted to show you before we get to questions is, how do you do it? So did you put the link on here? No? So can you pull up the website? So the IT catalog is where the order form lives. itcatalog.ucdavis.edu. We have it put up there. We have the link to cloud as well. And this gives you the IT service catalog is where a lot of these are stored. Finding AWS is very easy. You can search for it right here. And it gives you the link to the service. Also provides some information on the service, who you can contact with questions, rates, the type of products that are there. There's a link to the UC-wide contract, related knowledge base. There's a bunch of information here. So this is a great place to go to when you're settled in and you're looking to get service. This is where you go. So to get this service, you just click Order Now, the big Order Now button, and then there's a simple form to fill out. This form is if you're paying with a university purchasing card. Some of you have that set up already because there's a lot of people who are currently purchasing through P-cards. It used to not be supported, but now it is, which is great news. Welcome to the 21st century. So this is the form where you can fill out with that. Some groups want to pay through purchase order. So you can click on this link over here and fill out the form to put in a purchase order. You'll need a few more details, like your account string, the purchasing administrator, i.e. the person who's going to put in the purchase order into the billing systems, handle those sort of approvals. You can get here as well. I'll show you this form real quick because it's very short. This is if you already have the AWS account. You put in your number, the account email, the cardholder name, like what name is the card under. And then there's a couple of sections that are on all the forms. Estimated monthly spend. This is important for the billing folks. They got to have an idea. A lot of times you're using free tier credits. So you think to yourself, well, I'm going to put 0 because I'm not expecting to spend any money. You should not do that. You should put how much you think it will cost. This is important for the billing folks to have. So even if you actually don't spend this money, you should put here an estimate. So for instance, if your environment you spec'd out and it's going to cost you $15 a month to run, you would put 15 here, but what you're actually going to pay is the amount of money that AWS charges you. So if they charge you no money, you would still put 15 here, but your department's only going to get billed 0. Purpose, this is important to put in here so that we can verify that, you know, the stuff that's being stored here meets, you know, any UC Davis guidelines. If it doesn't, you know, we get in touch with you and have a dialogue about that to try to bring things into alignment. But this is one of those things that, you know, you fill out. Doesn't have to be long, but, you know, it should be concise and complete. We have a link to the information policy, the data sensitivity guide that I showed you earlier. And then finally, you know, some acknowledgements. You have to check these, so think about them. And finally, at the bottom, request information on the IT cloud brokerage. That's a way that, you know, we'll handle that billing for you so that you know, don't have interruption of business, you don't have outstanding credits, you know, all the credits get applied, et cetera, et cetera. So that's the form for P-card. The form for purchase order is the same, it just has a few more fields. Account number, email, same. This is the UC Davis account number to bill for services. And these are the billing folks. Your business operating unit for your department should have this information, or administrators in your department would have this information if you don't have it already. Purchasing administrator, that's the email of the person who's actually putting it in the system. So this is an important piece of information to find. This is part of why IT is trying to help people abstract this away so that you don't have to know all this stuff. Dean?
So for like regressing, should they more likely ask the PI to set up this account? So because that way if they leave the campus or go on somewhere else, they're not dealing with how do I transfer my account, my UC Davis address over to someone else?
That's a great question, actually. In an ideal world, that's true. But if I am to believe the reports from people like yourselves, usually the PI asks you to set everything up. Does that sound familiar to anybody? No? What we recommend is that the account set up under a departmental address or a simple list. Yeah. So in other words, don't use your email address, find something that can be used there. PI will have access to that sort of information. So again, monthly spend purpose, the rest is the same. So just wanted to make sure that you guys knew. IT catalog at ucdavis.edu. You can find the AWS form, sign up for it, because that way we can help you in the future. Yes?
I made a personal account and then I used this one to transfer it over to you guys, but I have not, I don't think the transfer, my credit card is still getting charged.
Right, so that one, that's Could be because the people handling the P card haven't switched it over. I can help facilitate that if you're still having issues. But yeah, if you already have an account and you want to switch, you're paying with your personal card, and you would rather have it paid with a departmental purchasing card, you can fill out the form and do that. Now, one thing to keep in mind is that this doesn't transfer things automatically, because you guys have signed up for your accounts, you guys hold the root credentials, you need to update it with the P card on the AWS Management Console. So that may be part of the problem. This form is to get the proper approvals, you know, to get it in the system that you are paying with a purchasing card, so the accounting and financial services folks know that. But what you actually have to do is put in that credit card number in the AWS Management Console.
I fill out this form, which I've already done.
Yep.
And then I have my administrator put the P card into my console.
Yes. Yeah.
Then I'm done.
Then that should be it. Yeah. So what's going to happen there is that the accounting and financial services folks know that you have gone through the approval to pay with a purchasing card, and then there'll be instructions for the person actually managing that payment to do it. I think one of the biggest benefits of the cloud brokerage and having us help set up the accounts for you is that all this stuff gets taken care of. It's been sort of this Gordian knot at the university that the payment processing for accounts has been a colossal pain. And you know, the best way to do it is to just cut it. You guys know the story of the Gordian knot, right? So, so that's what we're endeavoring to do. We're getting that set up, and then we're going to build on top of that services that the university can use, that anybody at the university can use as far as they're a member. So we made it, 11:55. We were going to set up office hours and just sit here and answer your questions in particular, but we booked this room for 3 hours.
You're welcome to stay.
Okay, so we have a few minutes, but I think that concludes our presentation. We'll hang out here. Thank you very much for sticking with us, and yeah, you can get in touch with us on cloud.uc.edu.
Tremendous amount of work preparing for this and getting the website out and all this processing going so it makes it easier for us to even consider using AWS. Thank you, really appreciate it.
Awesome.
Yeah, feel free, you're welcome to say ask questions or work, and we don't have another class.
Hi, Bob.